All right, lesson 7.3. Make sure we fill out the attendance, but I'm going to get started. The items we're going to need today, if you go to your digital classroom here and go to your daily, weekly links, I'm going to open up the formula chart. We're going to use that heavily today, but before I even click there, I'm going to open up my pre-programmed graphs. So I'll have that open and available for later on. But truly, for the bell ringer, what I'm going to be using is the formula chart. So now I'm going to go open up my formula chart and blow this up. And this might be a little bit different than you saw last class. I realized that there was a difference between the 2019, 2020 version and the 2020, 2021. And the 2021 is the, believe it or not, older version. The 2019 was an update, and this one is long story short, this is the better one. So I've changed it. It's going to be different than what you saw last time. A couple of these are flipped around, but you can tell the eccentricity better. And that's why I like this formula. Hopefully the district makes this a permanent switch back to use this one. Let me blow this up. We are going to look at number one, number two now. So number one says, write an equation in standard form for the ellipse with all this information. When you're working on conics, especially in pre-calculus, according to Texas, the TEKs are written that you should be able to write an equation given some key attributes. Those are my terminology. But write an equation, standard form, and we're looking at an ellipse. So what I'm going to do is go to the ellipse, and I'm going to draw off what's in common. And this is one of those changes. If you have a good memory, you'll realize this is different from last class. What's in common for an ellipse is that both formulas are going to start with some quantity being squared over a squared plus another quantity squared over b squared equals 1. So what I'm going to start off over here was with, I don't know what that first quantity is, but I do know it'll be placed over a squared, or in the numerator, and a squared in the denominator. And my second fraction, I don't know the numerator, but I do know the denominator will be b squared. All that will be set equal to 1. So that's what's common between the two formulas. And so I'm now going to start working with my information. When you see the word vertices, let's just do a little word association game. I want you to think of major axis, today there will be a new word, might not always be major, and we'll see that in a second. Or I want you to think 2a, that's the formula. So when I go to plot this, this is in the terms of x comma y. So we have x comma y. That means I do the x value first, then followed by the y value. So the vertices will be left 3, down 1. Left 3, down 1. And the other vertice is right 7, down 1. These are my two vertices. So like I said, I want you to associate with major axis, because major axis, what that means, it's a line that connects vertice to vertice. So that's your major axis. And I want you to think of the formula 2a, because from the center, it's a units left and a units right. So here's what I'm going to do. We're going to calculate 2a from here. This point is 3 to the left. This point is 7 to the right. Think in terms of distance. So it's a positive 3 left, a positive 7 right in distance terms. So how far apart are these 2 points? If it's 3 plus 7, 10 units apart. So 2a equals 10. That's our major axis. My question for the formula is I got to get to a squared. So I'm going to go step by step. What does 1a equal? If a equals 10, if 2a equals 10, what does 1a equal?
5.
5. And so for the formula, what does a squared equal? 25. So I'm going to replace this a squared with 25. And that also tells me another piece of information. Since this is the major, the vertices, and it's going left and right, this value here, the a, is going to go underneath the x, which means this goes underneath the y. The letters that are with them, if you notice, is minus h and minus k. So I'll put here minus h, minus k. I got that because the vertices are going left and right, horizontal. So it's the horizontal, it goes with the x. Now, since the a is 5, we can discover the center. The center is going to be 5 units from either one of these. So I'm going to start with the positive numbers. It's easier. From 7, what's 5 back? 2. So if I checked it 1, 2, 3, 4, 5, you'll see that's the center. 1, 2, 3, 4, 5. Yep, they match up. They're 5 on both sides. So the center is right 2, down 1. Close that parentheses. So when I put this parentheses, the values lie. So I'm not going to say x plus 2. When I put in parentheses, it's going to lie. It needs to be x minus 2 because the h itself is 2. That's the center follows the formula h comma k. So the center is going to be 2 for the x minus 2. And then the value in the y parenthesis is going to be y plus 1 because, again, inside lies. It's technically y minus negative 1. Net minus a negative 1 is a positive 1. Which leaves us only one thing left to do. Solve for b squared. Let's continue on our problem. So we found all that information, 3/4 of the answer based off vertices. Now it says foci. Foci, if you remember, are the reflection points. I want you to associate in your brain that foci is going to give you your 2c. So these points are left 2, down 1, left 2, down 1. There's a foci. And right 6, down 1. There's my other foci. So this length is 2c. If I count them, this is 2 to the left. This is 6 to the right. What is 2 plus 6? So 2c equals 8. What does 1c equal? C equals 4. And I know the problem does not ask for c, but on an ellipse, there is a relationship between the a, b, and c, and it follows this, that c squared equals a squared minus b squared. So we can say c squared equals a squared minus b squared, where we know c is 4, which implies that c squared is 16. So 16 will equal, and we know a squared is 25. 25 minus our b squared. Now, you might already know the answer is going to be 9 here, but if you did not, you would subtract 25, and we would discover that 16 minus 25 is a negative 9. Negative 9 equals negative b squared. If you're trying to isolate b squared, you would then divide by negative 1. And we divide by negative 1, we get that positive 9 equals b squared. And so that would be our value right there, 9. So that would be the ellipse. If you wanted to finish graphing it, with that's telling you that if b squared is 9, that b is 3. That means from the center, this ellipse would go up 3 units, and it would go down 3 units, 1, 2, 3. And that's what this, when I connect all my points here, I would get what this ellipse actually looks like. I'll use this one. The ellipse would look like that. That's what it would look like. But you don't have to have that on this problem. All right, and I didn't put on there the minor axis, but the minor axis is this distance across here. That would be the value 2b. All right, number 2, it says, again, write an equation. And so we will go to the formula chart and figure out the basic parts of the formula, but we need to get the ellipse. So when I go to ellipse, I'm going to copy off what I think is in common, what I see is in common between the two formulas, both vertical and horizontal. And just like last problem, it's a parenthesis being squared, or quantity squared, you could call it, over a squared, plus another quantity being squared, divided by b squared equals 1. Quantity is another way in math of just saying parentheses squared. Quantity squared, parentheses squared, equivalent to one another. All right, our co-vertices. Before I do anything, co-vertices, mental association. When you see co-vertices, I want you to think minor axis or 2b. So these co-vertices will give me the length of the minor axis. So I go to plot them. It says left 6, up 3, 1, 2, 3. That's a co-vertice. Right 2, up 3. That's a co-vertice. Now this gives me, again, some information. This point is 6 units to the left. This one's 2 units to the right. How far apart are these 2 points? If this one's 6 left and this one's 2 to the right?
8.
8. So if 2b equals 8, what does 1b equal? B equals 4. And b squared equals 16. Good, Mariana. I do hear you quietly, but I hear you. Okay, so when I go to plug this in, b squared is 16, so I can place that in the formula now. And the thing that goes with it, this is where kind of what students forget, is whoops, because this is moving left and right, these 2 points, they're left and right of one another, that means the x parenthesis is in the numerator with the 16 in the denominator, implying y has to be here. And so this will be y minus k, this will be your x minus h. If you look at the formula chart, that's the numerators. So I've established all that, and we can establish one more thing. If b equals 4, we could find the center. The center is 4 units from either one of these. So if you just count over 1, 2, 3, 4, you could check it and go 1, 2, 3, 4. Yep, it's 4 either way. So that means the center is left 2, up 3. So I'll go to plug this in. X, it says minus h. The h is a negative 2. So when it goes in the parentheses, is it going to actually say x minus 2? When it goes on the inside, it's inside lie. So it's actually going to say x plus 2, because technically you have x minus a negative 2. So x plus 2. And then I have a 3 here. So 3 substitutes in for k. And so when I erase that k and replace it with a 3, you notice it looks like y minus 3, the lie of a positive 3. We're 3/4 of the way done, all off of co-vertices. What's left? The a squared. Our problem, we find out the eccentricity is 3/5. That there is a formula for eccentricity here on the formula chart. The eccentricity is c divided by a for all shapes. So if eccentricity is c divided by a, I could substitute and say 3/5 equals c divided by a. That means my c is 3, my a is 5. For our problem, we only need a. So if a is 5, a squared would be 25. And so I've now plugged this in right here. Now I will tell you that sometimes it doesn't work quite as simple as this, because this could be a reduced fraction, meaning the numbers could be like, say, 6 and 10, something like that. But they'd have to follow that Pythagorean type of relationship, which our formula says, let me find that c squared equals a squared minus b squared. C squared equals a squared minus b squared. If you plug in your numbers and checked, you would see it does work out that these aren't reduced, these are the actual values. You could say, okay, we know that whatever this relationship is, I'm gonna just test it. Does 9 equal 25? 9 is c squared, by the way, 3 times 3. Does 9 equal 25 minus 16? And yes, it does. So this does work out for us. Sometimes though they might be reduced. So for example, if b would have been an 8, these would also need to have been doubled. So just be aware of that. But that's our bell ringer. With that, let's transition example.